Our solar system comprises the Sun star next to several objects orbiting it. The only part of the system that contains the planets of the solar system has a diameter of about 9 billion kilometers. Our planet Earth is located in a relatively small orbit in the interior of this system and this corner of space. Birth of the solar system. Our solar system formed 4.6 billion years ago from a massive cloud of gas and dust spinning slowly inside the Milky Way galaxy. Gradually, due to the force of gravity, this massive cloud condensed, and the speed of its rotation around itself increased. As the central regions of the cloud became denser, so did its temperature. This area eventually became the Sun. Around the central area were rotating plates of dust, gas, and ice. Inside the plates, particles of dust, gas, and ice coalesced to form structures called asteroids. These asteroids collided to create larger pieces called preplanets. Subsequent collisions between the protoplanets gave rise to 4 inner planets and the nuclei of 4 outer planets. Eventually, the outer planets could absorb large amounts of ambient gas and create the gigantic atmospheres surrounding those planets. Over the past 500 years, our understanding of the solar system has changed radically. Until the mid-16th century, it was commonly thought that the Earth was the center of the family instead of the Sun. In the late 1780s, the solar system was supposed to consist of only the Sun, 6 planets, and several comets. With the advent of the telescopic era and spaceflight, our understanding of the size of the solar system and the number of objects within this family changed, and we realized their greatness. This leap in our knowledge has explicitly occurred in the last 50 years. At the same time, our understanding of the rest of the visible universe has changed dramatically. Today we know that there are many solar systems in other parts of our galaxy where planets orbit stars other than the Sun. The Sun family. The Sun is the largest mass in our solar system, accounting for 99.85% of its mass. The other members of this family are 8 planets and their moons, several dwarf planets, and countless smaller particles and objects that can be divided into different categories, such as asteroids, comets, and Kuiper belt objects. Also, today, significant amounts of small pieces and fragments of rock, particles of dust, and ice leftover from the movement of comets along their path are left. The planets are mainly divided into 2 major categories. Those relatively smaller make up the inner planets of rock and the outer planets that are much larger. Orbits of the planets. The orbits of all the planets and asteroids are located on a plane known as the ecliptic. They all rotate counterclockwise around the Sun. Of course, if you look at it from the top of the solar system and above the North Pole. The time each planet orbits the Sun increases with distance from the Sun. For example, Mercury orbits the Sun once every 88 days at an average distance of 57.9 million kilometers. Venus orbits the Sun every 224.7 days at an approximate distance of 108.2 million kilometers. The Earth orbits the Sun at an average distance of 149.6 million kilometers every 365.3 days. Mars orbits the Sun every 687 days at an average distance of 227.9 million kilometers. Jupiter orbits the Sun at an average distance of 778.6 million kilometers every 11.9 years. Saturn orbits the Sun every 29.5 years at an average distance of 1.4 billion kilometers. Uranus orbits the Sun every 84 years at an average distance of 2.9 billion kilometers. Neptune orbits the Sun every 163.7 years at an average distance of 4.5 billion kilometers. Beyond Neptune. Beyond Neptune's orbit, two regions are densely packed with comets and comet-like icy bodies. Inland and closer to us is one of these areas known as the Kuiper belt, which extends from behind Neptune to about 12 billion kilometers from the Sun. Beyond that is a wide, spherical region estimated to be between 3 and 4 light-years in diameter, known as the Oort cloud. It is estimated that there are more than 1 trillion icy masses in this area. Inner planets. From outside the solar system, as you move toward the Sun, Mars, Earth, Venus, and Mercury make up the solar system's 4 inner or rocky planets. Earth is one of these relatively small worlds. Compact and mostly solid sphere, most of which is composed of rocks and metals. These planets have no rings around them, and the number of moons varies between 0 and 2. 4 inner planets. Although the 4 inner planets of the solar system are similar in internal structure, these worlds are different in appearance. Mars is known for its giant valleys and volcanoes, Earth for its oceans, Venus for its extreme heat and volcanic activity, and Mercury for its massive craters. All 4 solar system planets formed about 4.6 billion years ago at about the same time. They formed from materials that revolved in a plate-like structure around the newly formed Sun. These planets are made up of the materials that make up the inside of this page, in an area where only materials could exist in a liquid or solid form with high melting and boiling temperatures due to its high temperature. That is, metals, minerals, and rocks. The rest of the material evaporated under these conditions. During this process, rock and metal particles came together under the influence of gravity and by accidental collisions to form parts known as asteroids. These objects ranged from a few meters to several hundred kilometers but gradually collided and merged to form moon-sized objects several thousand kilometers in diameter, called protoplanets. Eventually, during terrible collisions, these protoplanets formed 4 massive rocky bodies that turned into rocky planets. Numerous collisions eventually led to inner planets forming generated enormous heat. That is why all these planets began their lives in a molten state. Because of these molten conditions, their ingredients were divided into 2 main parts in a process known as splitting. The denser materials, which mainly contained iron and metals such as nickel, went to the central and inner parts of the planet, and the lighter materials moved to the surface. Over time, the planets gradually cooled and, as a result, began to solidify from the outside in. The lighter layers near the planet's surface solidified into 2 rock layers. The thin outer layer is called the shell, and the thick layer below is called the mantle. In the depths of these rock layers, the matter that had accumulated in the planet's center formed its dense nuclei, which were made mostly of iron. Part of the Earth's core remains molten even to this day. Stone surfaces. In the early stages of their history, the inner planets were heavily bombarded by the remnants of planetary processes, and today, even after billions of years, these remnants sometimes hit the planets. Volcanic activity has occurred on all the inner planets, and these activities have affected the planets. On the surface of Mercury, most of these activities took place billions of years ago. The surface of Mars is home to huge volcanoes likely to have been dormant and inactive for millions of years. There are still active volcanoes on Earth and possibly on Venus. Volcanic activity, especially on the surface of Venus, has played an essential and influential role in shaping the planet's surface. Mars and Venus have atmospheres full of gases released by volcanic activity. On Earth and Mars, surface winds constantly change the appearance of the planet's surface. Of the inner planets, only Earth has liquid water on it. However, studies and evidence show that the surface of Mars has changed in the past due to the flow of water on it. Outer planets. The four outermost planets are Neptune, Uranus, Saturn, and Jupiter, respectively, farther away from the Sun. Each of these giant objects has a huge atmosphere and a large magnetic field, and there are many moons and systems of rings next to them. All the outer planets formed at about the same time on the outer surface of the rotating plane around the young Sun. This part of the plate, which was significantly cooler than the inside, contained a mass of fine ice, rock, and metal particles. As the particles grew larger, they absorbed large amounts of gas due to gravitational pull. Most of these gases were hydrogen and helium. They were placed around particles of ice and rock to form the deep layer of the atmosphere. Outer planets formed almost where they are today. In recent years, however, a theory suggests that the planets may have first formed in areas closer to the Sun and then migrated. For example, the two planets Uranus and Neptune are thought to have moved slightly away from the Sun since their inception, and Jupiter has moved slightly closer to the Sun. Astronomers think that if Jupiter's high gravity did not cause turbulence in the region and the protoplanets to fall apart, another planet could form in orbit between Mars and Jupiter. The remnants of these materials now include the main belt of asteroids. In terms of volume, the outer planets are between 58 and 1320 times the size of Earth. The outer planets each have atmospheres mostly composed of hydrogen and helium. Of course, the atmospheres of the planets Uranus and Neptune also contain methane. Images taken from four outer planets show that the upper layers of their atmosphere constantly change and are affected by strong winds and storms. All four planets have strong magnetic fields, but Jupiter has an exceptional magnetic field that is 14 times stronger than the Earth's magnetic field. Moons and rings. Each of the outer planets has a large number of moons. Larger moons formed simultaneously as their mother planets formed from the same material as those around the mother planet. The way these moons came into being is similar to the way the planets came to be from the primordial material around the Sun. Many of the smaller moons are unused building materials trapped in orbit by the solar system's outer planets. Most of these smaller moons have an irregular appearance consisting of ice and rock. Each of the four outer planets has subtle ring structures around it. The structure of these rings is different on each planet. Some rings are made of dust, others are small pieces the size of small boulders made of ice or rock or a combination of the two. Some rings may have existed around the planet since its inception. Others are probably moon's remnants that have been broken and shattered by collisions with each other or by the forces of the planet's gravitational field.